Hi, this is Dave Bedard, and we're going to go through the procedures of solving a probability problem, in this case, calculating Pearson's correlation coefficient by hand from scratch using the basic formulas. The formulas themselves, while they look to be rather complex, can be gone through step by step in a rather simple manner. But you have to know the formulas, as in anything in statistics or math in general. Without the definition, without the formulas, you're lost. So let's start off and let's take a look at the formula. So, what is the mathematical definition of Pearson's coefficient? We start off and we'll write this down as R, and it's going to be, which is what's typically used for Pearson's coefficient. And R is going to be equal to N, which is the number of samples that we have, times the sum of all of the X times Y minus the sum of all the X's times the sum of all the Y's. That's the numerator, and we're then going to take this and we're going to divide it by two radicals, which are very similar to one another. The first one is going to be N times the sum of the X squares minus the sum of all the X's, and I'm going to put parentheses around these to make sure we take the separate, squared. So this sounds weird, but they're slightly different. One is the sum of all the X squared, and then the other one is all the sum of all the X's squared. We find the difference. The next one is going to be the same thing, only with the Y's. So that's going to be N times the sum of all the Y's squared. So it's the sum of the Y squares minus the sum of the Y's, and I'm going to take that squared. That's the formula. It's straightforward, and we can find out the answer, but how? We don't have that information right now. We have our X's, and we have our Y's. So what we still have to calculate is going to be our X squared, our Y squared, and our XY's, and then takes the sum of those things. So we're going to do this by drawing a couple of columns here and run up the numbers. So let's go over to our next board and we'll see where we're starting from. Now I've cleaned up, so if you're recording this or saving this, there's our formula at the top, all nice and cleaned up. And we can set this up either in a spreadsheet or you can do it by hand. And you set up your columns. So each one of the samples we have here, samples 1 through 8. 8, of course, is going to be the number that we're going to use for N. And for each one of these samples, we have our X value, our Y value. We multiply those to get the X times Y. We then square the X to get the X squared. We keep these all in separate columns. And we square the Y's to get the Y squared. So for each one of these, once we get all these numbers, we take the numbers and we sum them up, which is the same thing as saying we add them up and we come up, we get the numbers. So there's our 142 is the sum of all my X's, which I've also put here for convenience on the right-hand side. We sum all the Y's and we get 563. And again, there's your number. We sum up all the XY's, get 10134. And we do this the same for the X squared and the Y squared, which are the last two numbers. All we have to do now is start putting them into the formula. So we can see our first part of the formula over here is N times the sum of the XY's. The sum of the XY's is 10134. So we have 8 times 10134. And then we subtract that times the sum of the X's times the sum of the Y's. Sum of the X's, sum of the Y's. We multiply those together. And then we take these, that's why I have these in parentheses. And then we subtract this multiplication from the other one. Once we do that, we'll get a value. We then do the bottom in two parts because we need to do two separate square roots. So we do the first part, and then the second part, and then we take the square root. Now, if you were to take these values as I've written them here, they work quite well with Excel. You can plop them in, and it'll actually do the numbers for you, or you can do it by hand. The bottom line is what we get is R is equal to 0.3909. And this is the by hand method of getting the answer that we're looking for. So there we have Pearson's correlation coefficient calculated by hand using one of the simplified formulas. Be careful. You go online or you go in your textbook, and they might have a slightly different formula. That doesn't mean that there's different formulas that have different meanings. Mathematically, they're all the same. They've just been reorganized in some ways to make the calculations by hand easier. I picked the one that's good for calculation by hand. When you're doing calculations by computer to avoid certain problems that can occur by using this method, they have a slightly different formula. So be careful when you're looking up your formulas in your book. The formulas that you have, each one is the same thing, just twisted around to be able to make the calculations better for a different way of calculating. I recommend this one if you're going to be calculating by hand. And that is the end.